This lecture is about advanced SQL. Um, in SQL, we use some functions like count distinct, summation, average, maximum, minimum. These are aggregate functions or aggregation operators that we use for calculations. For example, if we want to find the total number of sailors in a table, we can use select, count, and in parentheses, we use a star from sailors. If we want to find the average age of sailors who has rating 10, again, we can use a aggregation function in the select row. We can write select average s.age from sailors, which we call it S, where the rating equals 10. If we want to find the name of sailors whose ratings were maximum rating, first we should find the maximum rating in our table. We use nested query, select maximum rating from sailors. This nested query gives us a number. Then we can use this number in another query, select s.sname from table s sailors, we call it s, where the rating equals the number that we calculated in the nested query. To answer the following question, how many ratings does B have? We can select count of rating, and we can use distinct here because we want to know how many ratings or unique ratings that Bob has. So we can use distinct here from table sailors s, where s.s name also Bob. Find the name and age of the oldest sailor. Um, the oldest sailor means that the sailor whose age is maximum. To do that, we can find a maximum um, of age, but we cannot use maximum without any grouping. Um, for maximum, minimum, summation, and aggregated functions, mostly we use group by, right? We group them by another column, right? For example, to find age of the youngest sailor for each rating level, for example, SID, name, and the rating and the age, we can use group by. How can we use group by then? We can use of the aggregation function in the select command, and after the from, we can use group by to group the record based on the columns. Here we say select the rating and minimum age from sailors, but after that group them by rating, and after that we have rating and minimum age. Okay, find the age to find the age the youngest sailor. In general, we don't know how many ratings level exist. Um, and what the rating values for these levels are. That's why we should use group by here. Suppose we know that rating values go from 1 to 10. We can write 10 queries that looks like this. Uh, Select minimum age from sailors S where rating equals to, let's say, 1, and then for another rating select 2, and then another one rating equals 3, and so on and so forth. But we don't want to do that. We want to use a grouping feature. On the left side, you see our rating, an example. We have different ratings and we can see age. And we want to group the rating, group these records based on rating and use an aggregation function, let's say the minimum age, right? To do that, we should find all the one, all the three, and all the 7 and 8 and 10 ratings, and after that find the minimum for each group, okay? That's why we group them. And the next step, we can see one, and we have three records three, we have two records seven, two records eight, one record one, nine, and 10, right? And then after grouping the record, we should find the minimum number for age, right? Obviously, we have only one record for one, 33. We have three records here, 25.5. We have two records here, the minimum number is 35, right? And we have um, 8, and then we have two numbers again, 20.4, 0.5, right? But the age, all of these ages are greater than 18, right? And finally, we have these three, let's say, groups here. We have 3, 7, and 8. Why we choose these three? Because in the question say, for each rating, the level with at least two sailors. It means that we are not looking for sailors that have one value here. So we exclude rating 1, 9, and 10. That's why we have three groups here. So we group them, and after that, we find the minimum value, right? And to do that, we can use another condition named having, right? The difference between where and having is in the where condition, we apply the condition before group by, but having applies after the group by. To answer the question, find age of the youngest sailors with age greater than 18 for each rating level with at least two sailors. First of all, we should restrict our records to the sailors whose age is greater than 18. So we can use 18 here. So we don't do any group by or grouping here, but we just get the records that the records age is greater than 18. And after that, we group them by rating. When we find all this information here, then we are looking for those ones that have the minimum count is 2, right? That's why we write down count of the records is greater than 1, right? And then we will have these three numbers, right? Um, we have three tables here. It is another example. We have a student, we have course, we have takes. In student, we have three records, three columns. Again, course ID, name, credit. We have a student ID, course ID, and grade. And we want to answer the following queries. Find the student IDs with the highest grade in each course. Obviously, for answering these kinds of questions, we should use aggregation function. Highest, high number, maximum, minimum, at least two, or something like that. For these kind of questions, we should use aggregation function. Okay, find to find a student ID with highest grade. Um, One of the things that we can do is find the grade, the maximum grade from this table, and then after that join this table with a student and find the student names um, whose grade is maximum, right? We will go through different examples in MySQL or MySQL. But before going through the example, let's talk about join. We learned in a relational algebra what join means, right? When we want to get information from two tables, um, then we should connect the tables based on their common columns. Okay, if they don't have any common columns, we can do cross products, right? But how can we join the following tables? We have course ID, section ID, name and credit, and we have a student ID, course ID, section, and grade. We have two tables and you want to connect these two tables. As we can see, each course ID coming with a section ID, right? We have MG06, but there are two sections corresponding to each course ID, right? So it seems that we should connect these two tables based on two columns because it's wrong to connect these two columns just for course ID because we don't know the section ID afterwards. To do that, we can use either cross product and after that connecting two tables based on two columns. For example, select course, I call it course title, SSN, I call it the student number, from course and text, we call it C and T, and then connect the two tables based on their common columns. C.cid equals to T.cid and T.section equals to C.section. Another option, another approach that we have is using join. We can use inner join. Let's inner join two tables from course join to text. We can use inner join or just join to connect two tables based on their common columns on their common columns. But there are two columns, so we can write down C.cid equals to T.cid and T.section equals to C.section. Or we can use natural join because we learned from relational algebra that natural join connects two tables based on common columns, right? So we can use natural join and DBMS investigate the common columns of two tables and connects the tables based on their common columns. A student names who have taken database course. This is our query. So we are looking for database course, but we know that from this example, database course or the name of the course exists in course table. We are looking for a student name, but these two tables are not connected to each other, but they are connected through text table, right? So let's connect these three tables using join. Using join, we can select name, we call it a student name from course C, join text um, to course on their common columns. If they have section, we can connect them based on section. And then we join it with the student based on the student ID. And finally, we can apply the condition, which is where name equals to database, right? Basically, first we join two tables, course takes, and as the result of this operation, we have a joined table that can be joined again with a student based on the student ID. But there are different kinds of join, left outer join, right outer join, full outer join. But let's see what are the differences between these three kinds of joins. Left outer join returns a results table with the matched data from two tables plus the remaining rows of the left table, and null from the right column table, right? So apart from the joining records, we will have the left side table records, right? Who did not participate in the join. Example, give me the list of the students who have taken courses, right? Um, with their taken courses, it means that I want to see the list of students. Either they take the course or they don't take the course. Select the name of the students and the course ID from a student as left outer join to takes, right? We have the left side the student, right side takes, and then we join these two tables, left join. So the left side table is a student. Uh, so here we can see that in the text 2, 3, 4, and 2, uh, 5, 6, these two students taken a course, right? But not 1, 2, 3. Okay. But we bring 1, 2, 3 into the left outer join result. On the right side, we don't have any corresponding records, right? So this is called left outer join. We need to have the information from the left side table. What about right outer join? It's the opposite. Give me the list of records that who participated in this join operation plus the list of records on the right side that did not participate in the join operation. For example, all the grades with the course names, right? The left side we have takes, the right side we have course. Okay, we can see that 2, 3, we have MG06, MG06, MG0, and the section is 111, and we can see all these three records here from takes. But we have another course, MG06 section 2, that did not participate in the join, but we would like to see that record in the result. So as you can see, MG06 section 2 database, the credit 4, um, does not have any corresponding records on the text, but we can see that on the right side. What about full auto join? Full auto join says bring all the connected records plus the records from left hand side table plus the record from right side tables. It means that, okay, regardless of regardless if the records from the left hand side table participate in the join or not, bring them along with the right side records of the table. For example, here and the left side can see that there are some records 2, 3, 4, 2, 3, 4, 2, 5, 6, and 1, 2, 3. So we can bring all this information here. But on the right side, we have library information, a student ID and book ID, information about the students and the reserved book in the library. And we can see that apart from these four records that we have, right? We have another record here coming from the library table, 276 and 300. And on the other side, we can see that we don't have information about one student. We have a student about 123 who has taken a course but did not get any book from the library. So that's why on the right side we see null values. This is how full outer join works. Self join, we talked about this self join before. Find student IDs who have taken same grade in the same course. Um, when we want to see the records of a table next to each other, we can use self-relationship or self-join. It means that uh, just get another instance of this table, cross-product these two tables, and then you can see the columns of this table next to each other. Then we can compare the grades to each other. So here I say, okay, just create two instances of takes, T1 and T2. Select the student names, and their course should be the same, but the student ID should not be the same because we are looking for different students, and their grade should be the same as well. This query gives me the student IDs who have taken same grade in the same course. Um, Another comment in data manipulation language aspect of SQL is update. When we want to change something inside of one of the records, for example, change the city name of the student, change their age, change the course name, we can use update. And this is the notation in SQL. Update table name, set the field's name equals a new value, and there should be a where condition, right? If we don't use a where condition, it sets all the fields or columns to the new values, right? For example, change the grade of a student who has taken MG06 to 43 and lives in 32 King Street. So we have the address of the student. We know that this student has taken this course, MG06, and we should change it to the grade to 43. So update takes. We know that we should update information in takes table because the grade is in takes table. And then where CID equals to MG06, because the course number is MG06, and SSN equals to select SSN from the students where the address is 32 King Street. So there are two conditions in this query. First, the course ID, second is address. But we cannot um, see the address in the takes table because address exists in um, a student table. That's why we use nested query here. Another DML command of SQL is delete. We can delete records using delete commands. Delete a star from the table where condition, right? Delete the records in takes table for the students who have taken marketing course. Again, the course name is in the course table, so we should get the course ID from that table. So select the course ID from course where the name equals to marketing. This gives me the course ID. Now I have the course ID. I can use that course ID in my where condition, where CID equals that course ID that I fetched from a course table. Then delete all this information. Delete a star, or you can just write down delete from takes table where CID equals to this condition. Insert, when we want to insert records into a table, we can write insert into table name and fields, and then values, value 1, value 2, and add marketing course with section 2 and 3 credits to course table. Insert into course, list of the course columns, and then the values that we have. Okay. We can ignore writing the column names if we want to insert data into all the columns. But if you want to enter values into the columns, Then you should write the column names, some specific columns, let's say CID and section ID. You should write down CID and section ID and write down the values here. And it inserts this data course table.